Let me
Yeah.
just take a minute to introduce you while
Yeah.
you get started. Okay,
Yeah.
welcome everyone. We are very delighted to have Professor Andy Song with us. Professor Andy is from RMIT School of Science, Department of Computer Science and Information Technology. He's an associate professor in artificial intelligence at the university. He's the director of RMIT Artificial Intelligence Center. He's a Australian National AI Committee and is an active in the international AI field. He was a local co-chair of the top AI conference IJCI. He's also an OECD Forum partner, a B20 task force member. Professor Andy Song also serves as the AI director on several companies. Welcome, Professor, and we are super delighted to have you. And
Thank you very
without
much.
much ado, let me hand over the session to you and let's start with our AI session.
Okay. So let me get started. It's a great pleasure to present my understanding of AI to you. That hopefully will inspire you. So we will welcome you to study AI on preferably study in AI with us. So today I will give a very brief introduction on what is AI, and also I will tell you what actually AI can do, and also the impact of AI on the society. So basically, I would like to give you an overall view, so have like a quick start, and also give you the right foundation, because there's so many misconceptions floating around in the media, in the movie, and in the popular culture. So we try to get it right, because you, as a future scientist and the future programmer and the IT professionals, and hopefully you should have the right understanding of what is AI. Okay, so Romana already introduced me, so I would not repeat that. So that's myself. So when we talk about the word artificial intelligence, there's so many different concepts. So for example, people might think, oh, that's very, very sophisticated. And someone will say, oh, that's terrifying. It's a robot and a killing robot, and it was very threatening. And also some people might say, oh, wow, this can be romantic. I might have, I don't need to go through all the difficulties. I just buy a robot as my partner. Okay? So that's a different concept floating around. And also in the reality, you see different stories about AI. So for example, you see the human champion for Go was defeated by AI. Well, that was quite big news a few years ago. And also you can see AI actually can drive drive cars, those driverless cars, right? That's from Google. And also you can see AI used for facial recognition for phones. For now iPhones, they have the facial recognition, right, as a part of a security measure. So they can be used for different ways. They're all used in the many daily life technologies. So it's not strange anymore. You talk to your phone, say, Siri, find me this, Siri, find me that. Okay, so AI is already part of our life. Okay, and it will be even more, in the years to come. So now, from a technical point of view, we need we would like to see what is actually AI. Okay, so the first question to answer to that is actually what is intelligence. Right? Intelligence itself is actually very loosely defined. Okay, so it originated from a Latin word, means to comprehend and or to perceive. Okay, and it actually entails quite a large number of different meanings, and they don't really have a clear boundary to each other. They have a big overlap. So the words I laid here, understanding, learning, planning, problem solving, creativity, they all have an overlapping component. They're overlapping with each other. There's no clear boundary. You say this is understanding but not learning. Okay? Or this is learning but not understanding. Usually we can't do that. Okay, they have a huge overlap. And from a technical point of view, we want to say, if there's something is intelligent, then at least it needs two components. First, its ability to perceive. Okay? And the second is actually to act. So you can see here is a loop. So perceive, act, and when you act, you will actually update what you can perceive. So you see the road ahead of you, and then you walk down past the road, and then you see more things, and you adjust your path. Okay, and you continue to perceive new road things, and you keep doing that. So you walk from path A to point A to point B. Okay, so this is a necessity for AI, but not sufficient. What I mean by that is because many automated system can incorporate this loop. So I'll give you a very simple example is automated door. So automated door, like use simple infrared sensor and can see whether there's a coming pedestrian. And if there is a pedestrian coming, and open the door, right? And then continue to perceive is there's more, open the door. And if not, close the door. Okay, and do we see this kind of door is intelligent? Do we say the AI door, right? And ideally not. Why? Because it doesn't really do smart things. So it's just do simple sensing and react. Okay, but if the door can do something like, hey, I look this person, I look at this person looks suspicious, I don't want to open the door. Okay, or the person is, I don't think he is actually coming, his intention is coming inside, he is just walk past. All right, and in that case, I don't open the door. Or if there's many people coming, I will open the door for longer. If there's just small person or just one person coming, to save energy, I only make the door half open. Okay, and this you will consider, that's a very smart door, right? So because it can react based on the situation, okay, and it can have quite a different strategy for different scenarios. And then we can say, oh yeah, this sounds quite smart. No, that's part of intelligence. Okay? But this description doesn't really give us precise understanding or precise definition of what is intelligence. Okay? If you look at some textbook, some actually say AI is actually intelligence exhibited by machines. Okay, so it's this concept or this definition is not very helpful. Okay, so intelligence implemented on machine, like what I just described for the smart door. So we can see. Yeah, this sounds smart, but we can't have a very precise definition. And actually, still now, in the academic, in the AI community, there actually no such thing. So uniform definition of artificial intelligence, which is accepted by everyone. There's no such thing. But everyone will have slightly different interpretation. Okay, so you should be aware of that. But this definition I just gave you actually shows it has some link to human intelligence. Okay, so if we look at human intelligence, and so this is the definition. So later on, when you study AI, you will use a textbook. It is a modern approach to AI, and this definition is from that book. So it divides the definition into 4 aspects. So so you can see there's a 2 dimensions. One is think versus act, and another is whether it's like human or rational. Okay, so humans are not rational, and because we can be emotional and we can doing things without actually too much reasoning. Okay, and so there's 2 different approaches. So first, I want to behave like human, or I want to think as a human, or I want to think rationally, or I can act rationally. So act and think, they don't really necessarily be the same, because the thinking procedure can be, you can say, if it's not really rational, but the act is quite rational. So which means we don't really know what the program is doing, but we do know how the program actually behaves. Okay, so one of the typical example of that is deep learning. when you train a deep learning model, so a deep learning can play Go, can drive a car, but we don't understand. We don't understand what it's actually doing. But we can, we know it will do the right thing at the most, with 99% of accuracy. Okay, so this is act rationally, but not think rationally. Okay, but we have all different four scenarios. So I would not expand. So if you are interested, you can so you can read the book, and we can also have a discussion later on. And another approach of finding intelligence is actually the Turing test. Say, I'm not going to bother to give a definition. I will just say I want to test. If the system or algorithm can pass this test, I will consider it intelligent. Okay. One of the example is a Turing test. It's probably one of the most famous tests for artificial intelligence. So it's developed by Alan Turing. So that's Turing, the Turing Award in 1950. Okay, so the task is to test a machine whether it actually can behave like humans. So another human cannot tell the difference. So the diagram is like this. So we have a computer, and so this computer, and this is the human. Okay, and this is the wall. Okay, and on the other side of the wall, there's an interrogator. So the interrogator going to communicate through the wall. Okay, is it from a wire or from whatever the mean? And if the computer can fool the interrogator, so to make the interrogator think he or she is actually communicate with a real human, which is B here, and then we'll say this computer actually passed the Turing test. Okay, so it's the at the time of it being proposed, it sounds very, very daunting task. Okay, and it has been one of the jewelry of the crown for AI. But later on, people actually find this, even passing Turing test is still not enough. Okay, because the test itself is actually only text-based. So which means you send a text, a telegram or type, and then the other side you send a text. Okay, so if you have a robot, so like a face-to-face conversation, it's actually really, really difficult for a human to say this is actually a human, a real human, because a human can tell the difference between a machine and a human very quickly. Right? So it's still unsolved problem. So that's to give you some basic idea of what is AI. So it's nothing glorious about the concept of AI. So then the task is, okay, so if you don't have a clear definition of AI, and you can't pass the Turing test, so why you learn AI? So what the AI can do, okay? So or how to do AI? So actually, the AI can be very, very useful. So I'm going to give you some examples. So, and when you actually want to study AI or doing projects related to AI, you will find actually AI concepts come from many, many different disciplines. For example, philosophy, mathematics, psychology, neuroscience, economy, computer engineering, linguistics, and the list go on and on and on. Okay, there's many, many different approaches. But fundamentally, what I like to tell you is actually search. Okay, so this word search, and you will say, oh, that's easy. I know search engine like a Google, right? Google is a search engine, so it's an engine for search, right? But in AI, the concept of search is slightly different. In the Google sense of search, is I'm searching for information, it's already there. Okay, so on Google on a different web page, I try to find a website. Okay, if I cannot find, I just return could not be found. Okay, so that's a search for existing information. Okay, but searching in AI is exactly the same word, but has quite a different meaning. So means search for possibilities. Okay, I'll give you example now. What I mean by that? So now look at this typical example. So it's called traveling salesman problem, right? And this is actually very simple. For human, it's trivial. So you can see number one, the node one. So this is the map, okay? So all the numbers here, all the nodes are cities, okay? So now I have on this map, I have 7 cities. So the number between 2 cities means the travel distance or the cost. Okay, for example, from A to 2 will be 12 minutes. From 1 to 2 will be 12 minutes. From 1 to 3 will be 10 minutes. Okay, so on and so forth. So the task is I'm now starting from 1, okay, city 1, and I want to go to city 5. Show me the shortest path. Okay, and for human that's trivial. So I'll just go to 1 to 3, 3 to 5, and that's it. Okay, and the question is, can we use AI to actually solve it, right? And especially when the number of cities are beyond human abilities. So like I have 100 cities or have 100 different places, and find me the shortest path. Okay, and if you use your phone, the smartphone can do that. Okay, you can consider as kind of solve the problem. Okay, but how it can be achieved? So what are we trying to do is actually we need a search for all the possibilities. So from 1 to 5, actually 1, 3, 5 is not the only path. Okay, we can go 1, 2, 4, 5. We can go 1, 7, 5. Right? We can even go 1, 7, 6, 5. Okay, so there are different combinations, but among all these combinations, 1, 3, 5 is the shortest. The shortest distance only 13, so 10 plus 3. So therefore, I choose this path as my solution. Okay, so fundamentally, search in AI is just that simple. I search through all the possibilities and find the best possibility, which is the optimal solution. Okay, and if you use this concept, let's expand that to a game. Okay, so this is a game. So sometimes when we heard the news, the human champion has been defeated by AI. Now AI is going to take over the world, and the game is usually used as an example. Okay, so it creates some fears. Okay, but if you look at this example, it's actually nothing to be feared. Okay, it's human design method, which you can write a program. Okay, if you're doing AI, you probably will ask to write a program to achieve that. So, but the principle is actually rather simple. You don't need much technical details to understand how it works. So, for example, I only have like a 3x3 chessboard. Okay, and I'm holding the white. Okay, I'm on the white, and my move. So, so this is bishop, and I'm not sure whether let me try to highlight this. So you can see. So, okay, some highlight. So this is my piece, okay? And now there's 2 possibilities. I can either take the knight here, or I can take the black bishop. That's 2 possibilities. So the first possibility leads to here, okay? And the second possibility leads to here. Okay, I draw this on the piece of paper, okay, like a tree. Okay, we call it search tree. Okay, but you can draw it on paper. So if I take the knight on the left, the black knight, okay, so what my opponent would do? So the black player. So the black player is very, very possible it will use this castle and to take my bishop, which end up with here, which is this situation. So my piece is gone, now killed. And this is bad situation. And then I say, I don't like this. So I give this value -80, very bad for me, okay? But if I move here on the right, and my components, what they can do, there's all 4 possibilities for my opponent. It can either move the castle here, So you can move the cursor here, or move the cursor here, or move the knight here, or move the knight here. There's 4 different moves, and none of the move would hurt me. Okay, so not ideal, but would not hurt me. So therefore, I can compare. So which one is better for me? Of course, this one is better. You see, so this one is a better choice for me. Okay, therefore I choose this one. Okay, so this is just the simple principle. Okay, and for in 1998, there's a machine, you might have heard of that. It's called Deep Blue. Okay, and it defeated the world chess world champion Kasparov. Okay, from Russia. So at that time, this actually was done by IBM, and so it's actually follow exactly the same principle I just described to you here. But the only trouble is the machine they built actually can go 40 levels. So here I only show 2 levels, right? 1, 2. But the Deep Blue actually goes 40 levels. So which means you can imagine if I go to 40 levels, it will grow very, very fast. So which means I need lots of memory, I need lots of computational power. Okay? And the human, it's very difficult for human go for 40 levels. So what actually mean by 40 level? 40 level means 20 steps ahead. So I can look ahead 20 steps. Okay, at least 20 steps. So your move, my move, your move, my move. Okay. So if you have this mechanism, you can and you have enough power, computational power, and you can defeat pretty much anyone. Okay, no one can defeat you. So that's the principle. I'm using search to play game against a human. Okay, and also I can do even better. I can say I don't need to write such algorithm. So the algorithm I just showed you before is actually written by human and designed by human. Okay, and then later on, people say I can even search for the better strategy rather than search for the best move. Yep. So that's actually what's been done several years ago by Google. That's I'm using learning to learn a player. So they use learning, the same algorithm, to start with very bad. I want to play with a world champion software for playing chess. Okay, and then this is that's a shugi, and this is go. Okay, so initially it's very bad, but it's actually trying to improve itself. And after several, like you can see here, let me highlight here. If say around this time, okay, around this time. So that's actually 200,000 steps. So there's a massive amount of computation being thrown into this. So then it actually can beat the best program called Stockfish. Okay, and then here Sogi is slightly simpler. So around 100,000 steps, it can beat the best program, Elmo. Okay, and then later on, that's actually beaten the AlphaGo 0 and AlphaGo Lee. So AlphaGo Lee is the program defeated human champion. Okay, and then this learning algorithm is actually defeat the human written program, AlphaGo Lee. Okay, so it's still search, and you can even see the progression of the search. So the performance getting better and better. So it's actually searching for different possibilities and find which possibility is better at playing the game. Okay, so that's why I say AI as a search. So and then so now if now you get the concept, using AI is just actually come up with a search algorithm. Okay, but not search for information, but search for possibilities. Okay, and then for chess, Go, and this kind of game, you search for the next best move. Okay, and for voice recognition, is actually search for best matching word. Okay, and for share market prediction, it's actually search for future scenarios. Right, and for and for other problems is if you can turn that problem into a search problem and AI can solve it. No, theoretically, yes, this is true. And that's why in 1960s, and the top AI scientists, that's a claim, okay? They say machine will be capable within 20 years. Remember, this is the 1960s, of doing any work a man can do, okay? And now it's 2020. That's still it's still a false statement, okay? So why? What's wrong? Okay, what's the problem? And people actually quickly find another concept is hidden. It's called complexity. So which means the problem can grow very, very fast. Okay. So if you search for the travel salesman problem I described before, if you only 3 cities, it's trivial. Okay. And if you have 10 cities, it's a little bit more. If 100 cities, it's not 10 times. It's actually actually exponentially more. Okay, so it's become a number so large that human cannot handle, and even computer it's very find difficult to handle. So many computer for modern computers and for many it takes several thousand years to compute. So which means we don't really have the capability to compute to find the solution. Theoretically, yes, but in practical sense, we cannot. Okay, and so that's another reason why deep learning become so popular in the recent years, is because deep learning can reduce the search, can be a little bit smarter. So I don't have to search all possibilities. I only search for the possibilities which are promising. Okay, for most of solutions, I'm not going to look at them at all. Okay, so I can achieve that similar task or achieve reasonable performance by reducing the search space. Okay, that's different ways. Okay, we wouldn't go too far on that. So that's the complexity. And then now, if you understand this, then you will see why we have such AI history. So it appears, so in terms of AI, it has been in the human imagination and the literature for a long time ago, like several thousand years. I think some of the literature, like 800 years ago, already have the concept of automated machine, automated man. Okay, and the concept is introduced in 1950s, okay? And the term artificial intelligence was coined in 1956 in the Dartmouth conference. Okay, and then everyone was excited. So I showed you in 1960s, but soon after they found the problem I just described. So that's AI winter. So people don't believe AI scientists anymore. Okay, it's actually not the fault of AI. Okay, and then the boom after that is 1980s, 1987. Is an expert system. So get human involved to research. And then later on, it get another winter, right? And because human experts sometimes is too, they don't have the patience, okay, to share their knowledge. Okay? AI has grown steadily and become very successful in many fields. It's because of the computation, the computation power has grown so much, and also we found a better approach. Right? And now you can see the AlphaGo, DAPA test, FacePay, iPhone, and so on and so forth. There's so many different technologies around you. So if you like to go for AI study, there's a different approaches. I wouldn't go through. There's a 5 main approach, and all of them are just different, if you like. Okay, slightly different. So they approach the search problem in a slightly different way. Okay, I would not expand, but you know the fundamental. But now let's get into tell me what the AI can do. Okay, there's no such thing as a AI program. Okay, because usually AI algorithm is specific to the task. It's no general AI, so can do everything. Okay, it's not possible because first I need to identify the problem, and then I come up to solve it. So then what we need to do, tell me, and then I need to convert that into a search problem, and then I can use different AI technique. So understanding of the problem itself is actually it's critical. Okay, so without that you can't proceed. So no matter how fancy your algorithm cannot solve that problem. Okay, so there's a certain element. The goal of the task need to be well defined. Okay, and the problem also can be represented computation. Okay, and evaluation of the solution is computable. So it means can be measured numerically. So for example, I want to say I want to write a program to tell jokes, right? And so therefore I need to find a way to measure how funny a joke is. But the problem is, how are you going to measure funny, right? So what is funny? And what's the numerical representation of how funny a joke is? Right? And so if you can solve that problem, and you can turn it into AI problem, okay? And if you cannot, and then we, as AI scientists, you cannot actually turn it into an AI program, okay? And like that. So it cannot define, and also you cannot compute, right? So once you can do all what I just said before, feasible search technique to solve the problem. Usually, the last part is okay. Let's look at some range of tasks. So remember, as I mentioned before, there's no universal or general AI technique can solve all problems. Okay, so for different tasks, we define an AI technique. Okay, or AI algorithm. Okay, the underlying principle might be the same, but the actual problem or actual program, they will be different. Okay, so you can't copy the code for medical diagnosis actually to drive a car. It can't. Or even for we was actually joking around by for the Go player, the AlphaGo. So AlphaGo can actually can defeat the human champion, but it can't play chess. It can't play mahjong. It can't play poker, right? So it only is actually specifically designed for Go. Okay, to human. Okay. So if we look at the tasks, so there are certain tasks. Then, for example, here, tic-tac-toe, connect four, checkers, Rubik cube, and this task, AI is guaranteed can find the optimal solution, right? So there's no possibility a human can perform better, okay? Because you can write a program to find the optimal solution, okay? And there's another is called Superhuman AI. So which means AI can always perform better than all human beings, okay? Unless it's written by a poor programmer. Okay? If you write it in a correct way, and you have enough computational power, and human cannot cannot actually win over the game. Okay, so chess, Go, scramble, Othello, and so on and so forth, all like that. And also that's a high human AI, so which means for most of human, they cannot defeat the AI program. But for some really expert, really smart people, they can, and they may have a better chance. Okay, so I'm not going to read that, so you can see here. And also there's a par-human, so which means similar to human, like the car, read handwritten notes, classify photos, and so on and so forth. They're very, very similar to average human being. Okay, and then also there are subhumans, which means it's very difficult to achieve human performance at these tasks. So, for example, I want object recognition and speech recognition. natural language processing. So Siri, so if you talk to Siri, it can, it's not a guarantee 100% accuracy, say, to can understand what you're trying to say, okay? On also navigation. So if you try to program a robot to walk through a very busy shopping complex, it's you will easily find it's very challenging task. But for human, like even for a 5-year-old child, it's very easy. Okay, you don't take much thought. Okay, and also creating arts and also put a babysitting. So actually, no one wants their baby being looked after by robot or computer, right? But so for these tasks, AI algorithms are still hopeless. Okay, and actually, it's not really because not only because algorithm itself, it's actually because we cannot translate that problem well enough to be a good problem to be solved by AI programs. Okay. So and like to highlight is some specialized field. Okay, and you probably often sometimes you often heard people talking about AI taking jobs. Sometimes actually they're talking about this type of jobs. So the AI actually can perform similar or worse than expert on a task, which is too difficult for any untrained human. Okay, so the list like law, translation, medical diagnosis, logistic operation, strategic decision, and news reporting. So for a human, for an untrained person, it's almost impossible to do that. So which means for these tasks, you need qualification, okay? So that's usually involve 3, 4, and even 5 or 10 years training, okay? In the case of medical diagnosis. But for machine, it's you probably program for 1 year, it can achieve very similar result and sometimes even higher accuracy than human, okay? So that's highly likely. It's actually that will I shouldn't use the word replacing. It will actually helping or assist human to do this kind of tasks. Okay, so this is actually the relationship between AI and the jobs and all the different tasks. So when you talk about what AI can do, you need actually first to look at what's the problem, right? So algorithm is actually not important. Is actually the problem is that important. But another question I've been often been asked is, can AI love? All right, that's actually a very it's a topic in many Hollywood movies. Okay, a robot fall in love and you fall in love, and I can tell you can fall in love with a robot or your AI program, and we love you to fall in love with AI, but AI would not love back. Okay, because that's not really a technical question. And AI is a program, is signals. Okay, it doesn't really have the capability or the mechanism to love. Okay, so and that's actually touched some of the high level human intelligence topics of like emotion, desire, consciousness, relationships, and the meaning of life, and etc. etc. Okay, but AI actually can be used for emotion analysis. Okay, so this is kind of some of the tasks I'm going to illustrate to you. So, for example, recognize the face. What's the anxiety? What's the sadness index, and so. That's actually very useful for business. Okay, to analyze what's your customer feedback, your customer sentimental, and so you can adjust accordingly. Okay, and also when we talk about the customer, you can. That's another example to help business. Excuse me. to look to predict where the customer will look at. Right? This we call saliency analysis, and then we would like to place the goods into the most prominent area, so there's a higher chance to be purchased. Okay, so that's a salience analysis, and also AI can be extended to enhance human capabilities. So you can see some examples. Take care of a patient, and also it's smart wheelchair, and then smart walking sticks, and also rescue. So the rescue and the diver, and also the different operations. Okay, especially in the dangerous places, and also AI can be used for social good. Okay, so for different social good, and that's a list from McKinsey Global Institute. Okay, so the goal of a better society is, for example, the reduced inequality, no poverty, life on land, and quality education, and so on and so forth. And AI can actually contribute to all of this. Okay, and at a different degree. Okay, so I would not elaborate on this, and if you like, you can go to this source and read about that. So, and also nowadays, because of the COVID-19, the economy is actually not in good shape. So we'll ask, whether AI can help economy. It's definitely yes. Okay, because the ultimate goal of AI is actually to solve a problem. So, and in the business sense, is actually to solve a problem which might be tedious for human, or it might be costly. Okay, so the use of AI actually can improve productivity and reduce cost, and introduce new service, introduce new business, and nowadays automate like a remote control, and remotely working in some potentially dangerous and risky environment. Okay, so if you look at the investment in the AI space, so you can so I haven't updated that figure for recently yet, but you can see the trend. So on a different area, so North America, it's a rapid growth in terms of investment in AI. Asia, very fast. Europe, very fast. Okay, and also if that's actually from PwC, this global economy impact of AI, you can see on the different areas. This I'm not sure whether this figure will be still true, but because this is actually pre-COVID-19, so that's the figure on 2030. Okay, but you will see the ballpark of that. So it might not be as big, but will still big to create more opportunities and create more prosperities for business and for economy. And then you might ask, what kind of areas AI might contribute most? So, and the PwC actually outlined 4 different areas, and I agree with them. Okay, so first, professional services. So, for example, taking accounts and taking advices, laws, and also bookkeeping and all these kind of tasks, and can be automated, and it can be highly assisted by AI programs. Okay, and the financial services, like that's a fancy term you might have heard of. It's called fintech. Okay, so AI is actually core part of the fintech. Okay, another is blockchain. Right, so to improve financial services, and also manufacturing, so automate a car factory. Okay, that's highly automated, and also wholesale and the retail industry that include logistics. When we say logistics, you probably will think of driverless trucks. Okay, and they are coming. Okay, and then I will give some concrete examples. So first is this actually are the projects or the the initiatives actually what I have been involved in. So for the first one is warehouse optimization. So I have a warehouse and I want to arrange the warehouse accordingly so the total operational cost, can be reduced. Okay. So actually what we did is because the particular warehouse we worked with has over 10,000 items, so we use the AI techniques to actually try to help the arrangement. So they actually could save about 40% of cost. Okay, so it's actually not because AI is so smart. It's actually it's actually because the human operators are too lazy to put them in a good way. Okay, so just with a little bit of effort, the program can find big margin to save the operational cost. And also for scheduling, routing. So as I mentioned, for vehicle routing on Google Maps on your phone, and so for truck delivery, and for fleet management. Okay, to find it actually. For example, this figure is not from me. The 2% is from one of my colleagues. So he worked for General Motors, and his AI solution actually saved 2% of the total cost. Okay, and for General Motors, and you might think, oh, what's 2%? 2% is a very small number, but for a company, because the base is huge, it's several billion. So several billion times 2% is still a very, very significant number. And also chatbot. So you actually find there's many companies that start actually using chatbots. So they are moving towards the automated answering machine. So but you might argue, you say, hey, look, this kind of chatbot or the automation, they're not perfect. Okay, and while I talk to it, it sounds stupid. So why they bother? So would they actually worried about this actually will scared of or piss off? No, the customer will piss off, so will not come back. Actually not, right? Because when they see, because at the back end they have a kind of evaluation. If the conversation didn't go well, human operator will step in. Okay, so which means the chatbot will handle a big chunk of simple questions. For difficult questions, still human. So which means significantly reduce the human effort. Okay, so and for the company, it can significantly reduce the number of human operators. It cannot completely replace them, okay, but will significantly reduce total number. So cost saving, okay, and also trust. So you can have a mechanism to measure the trustworthiness of a business based on the previous behavior, and so on and so forth. You can analyze this. So that's can help the economy as well. Another question, I know I've been throwing quite a lot of concepts to you. So, I think this is the last concept. After that, I'm happy to actually take questions. So another thing question I've been often asked is creativity. So people will say, yeah, human is very creative, and so the machine cannot. So therefore, we should be focusing on creative jobs, right? So for artists and all this, and so AI cannot be creative. In a sense, from AI perspective, that's actually not true. Okay, in some sense, this AI program can be creative because it can create a solution that human have not thought of. Okay, so and it is possible, and one of the AI techniques. So you know later on, if you get into this area, it's called genetic programming, which is one of my research focus. This technique can generate a pattern. All right, it's already been proved. So this is probably the only technique or AI technique can generate a real pattern and being filed and being approved. Okay, so for a patent, you can say no, a patent has to be creative. Okay, so one of the criteria. So for something to be patentable, okay. So it because some of the strategy, so this AI technique or GP actually can find something human can never think of, okay, have never thought of. So this is the example. So this example is what the heck? It is actually antenna. It's a for satellite. It's a satellite antenna designed by this AI program, okay? And it's actually better than any human designed, okay? Why is that? Because human always think the design should be symmetric, right? Symmetric, okay? So like mirroring to each other. But actually the best solution is not. As you can see, it's kind of organic. It's like a twig, okay? So it defeated the human in that way. So you can't say AI is not creative. So it can be creative. So if you look at the creativity from AI point of view, creativity is actually not that glorious. So first, there's two components. First, you explore different combination, and the second, you evaluate. And so good one, keep them, bad one, reject them. And that's about it. And if you have enough computational power, and you can search through all the combinations, and then you can exhaust all the possibilities, then there's no creative, that's in that thing, you already exhausted the pool of what can be created. So, all right. So and if you want to do that, one of the technique, and when you study AI, you will know it's actually use random. So random is actually very, very powerful. Okay, you use random and go search from different area and then find the creative solutions. Okay, so I will not. So if you are interested, we can expand the discussion later on. So here I would actually like to conclude my my talk. So I think the AI, is our future, and our future will not be taken by AI, but it will be a future actually full of AI. So we'll see AI actually serving human, and will be actually enhancing our society in many, many different ways. Okay. All right. So that's my talk, and thank you very much. So I stop here. Any questions? Hello. Okay. Now, yeah.
Hello, sir. So, Professor, there's a question from Ronak. What are the job opportunities in AI?
Okay. So actually, funny to you ask that question. So it's in high demand, really, really high demand, and many companies I think around the globe, they are willing to pay big dollars. And some of our PhD, they get a ridiculous salary, just working in AI, because clearly that's a need. But the trouble is, AI is very focused on research. So which means usually this job, they want a PhD degree. That's usually the case. Sometimes they can compromise. They can say, okay, if you have a master, okay, and you have some experience, we also accept you. But ideally, it will be a PhD or even postdoc. It will be better, which means you already been working on a real AI project after your graduation from PhD, right? And then you will be a really high demand.
Okay, thank you, sir.
Yeah.
There is a question which has come up twice. How does AI or GP work? I think sir has already spoken about a genetic path.
Oh,
That's
Yes. I don't think I can. It's at least I need a half an hour to explain that.
Yeah.
So
Yeah.
So
You,
So it's a quite it has quite lots of components and the prior knowledge you need to acquire and to explain how GP works.
absolutely.
Yes.
So there's another
Yeah.
question. What degrees are needed to enter this field? Siddesh has asked this question. What degrees are required to enter AI?
Yes, and usually for AI, there's actually two different streams from my point of view, right? And one is the typical computer science, data science stream. Okay, so people come from, and then they will be focusing on developing or improving AI algorithms to solve a particular problem. Okay, and that's one. And the second stream is people already from a different field, and then use AI and they taking AI approach to work on the problem in their own field. So I give you an example. I have a PhD student who is a civil engineer. He's from civil engineering, and his task is how to design a building, or how to control the air conditioning system so can reduce the overall energy consumption, right? And then he applied AI. So he used AI for his field. And I don't really understand the civil engineering, right?
Okay.
But he can pick my brain for what kind of AI techniques might be useful and how to conduct research and how to. So there's a kind of a synergy between AI and his own field.
Okay.
Okay, and this work quite well, and we've seen many examples. For example, medical design drugs. That's one. And we for AI people, we cannot design drugs. It has to be people from pharmaceutical background, and then learn a bit of AI, and then do that.
Okay.
All right, and also architecture design and so on and so forth. Yes.
Okay, so there's a question, can someone with a commerce or a business background enter this field?
Oh yes, funny to say, I also have another student actually from business background. So they want to apply an AI on business analytics, especially for say the particular topic is actually predict the movement of CEOs, the executives, to try to predict whether they would like to jump to another another position or another, something like that.
Okay.
Okay, so there is a pattern. But I'm not expert on business.
Okay.
But our AI techniques actually can help.
Okay.
To do that. Yes.
Okay, so there is another question. Is there a need to have a prerequisite to have a command on coding in any language to enter AI?
No. And you need of course you need an understanding of how to program, and that's a must. We usually we don't really concern, because our for our requirement is we give you 10 days, you can actually learn any language. So and you might have a program written in C and a program written in Java, and we just give you the program and go and run it, right? And try to figure out and improve it. But the good news is nowadays and the current AI, most of AI packages are written in Python. So Python now start emerging, become of the language of AI. It was not like that a few years ago, but now Python become very, very popular in the among data scientists and the AI scientists.
Okay.
Because the top-notch AI packages are all written in Python. Because for simplicity, write Python is really simple compared to other languages.
Okay.
Yes.
Okay, we only have a couple of minutes before this session closes. So there is a question
Sure.
around would Can this class be taken online, or do I have to come to RMIT Melbourne to do this program?
Oh, I'm not sure, but I think we do accept the online student at the moment because of such a situation, and my hope is we will open the campus very soon, hopefully,
Yes.
very soon. And also, I think the visa condition has been relaxed quite a bit. So we will open the door and welcome student. I think it's better than it's actually my own experience because of lockdown. So I actually had the first semester all taught in online, and the experience for both student and the lecturer are not ideal, I think. No, in comparison with on campus. So on campus is definitely better.
But is there an online offering of the program? I think offline, I mean, is there the artificial intelligence, can a student actually choose to do entire program online, is what she's asking.
I think that's a good question. I'm probably not the best person.
Okay.
We do have a master of AI.
Okay.
I assume it will.
Okay.
But don't quote me.
Okay.
Yeah, because our many courses are actually online.
Yeah, you should go to the booth here and find that out, Surbi.
Yes. Yes.
Yeah, there are a lot of questions which will be going to be preferable going for an MBA or sticking to a technical course for someone from data engineering background with 5 years of experience. So do you think doing an MBA will land you in this field, AI, or should they go further on data engineering background?
It depends on what the career path.
Yeah.
For MBA, as I said, if you have a very strong experience in business, and you want to apply AI into that field, I think that's a good choice. That's a good combination. But if you say I want to do speech recognition, I want to do machine vision, and so that's has a very little to do with MBA, and so probably not a very good choice unless that one exception is you want to do a startup, and then MBA experience will tremendously help that journey.
Yeah.
Yes, so there are many AI startups, but personally, I think that's a very difficult path, and a very low success rate.
Okay.
But of course, if you succeed, it's very
Lucrative.
good, very good return.
Yeah.
Very good return. Yeah.
Yeah.
But you need to be aware of the risk.
Yeah. Yeah. So one last question, I think, before we wrap up, what should one be doing after learning the syntax of a programming language like Python? What basic project should one work on?
Oh, yes. So there are many courses actually lead into AI. So for example, that one is called data structure, and another is called computing theory. And then you will take a course called artificial intelligence. And also there are projects. And if some of the projects may have the research component. And then if you see that, you can take on and you practice your AI techniques you learned from the AI courses. Okay, so programming itself is a must, but you still need a little bit more. So the knowledge of data structure and also data analytics and AI and all that, and then you need really experience. So you need to practice that in a project, and then you can move on. Okay, and ideally, if you have some publication, so you achieved something, and then you can write about it and you publish somewhere, and that's a big plus.
Okay.
If you want to move on to the AI field.
Okay. Thank you, sir. And I think you were very patient with all our questions. And
no worries, pleasure.
Okay, thank you very much. And hope our students are feeling inspired to take up AI after your masterclass. Thank you very much.
Yeah. Thank you.
Okay, guys, hang on. There are a lot of sessions happening now. Yes, professors, you want to say a few final comments?
Oh, no. In that case, if you don't need me, I will log off.
Yes.
Yeah. Okay. Thank you very much.
Okay, we are closing this session in another 30 seconds.
Yes, bye.
Thank you, guys. Hang on. There are more sessions happening. move on to the next one. Okay, bye. Thank you, sir.